In this video, we are continuing with the tangent properties. Now, we are given a right angle triangle ABC, which is right angled at A. So, angle A is 90 degree, and he has also given us the length of AC as 12 centimeter, length of BC as 13 centimeter, and there is a circle which is inscribed inside a triangle. So what do we mean by a circle inscribed in a triangle? It means that all the three sides of the triangle act as tangents, three tangents to this circle, right? So then he is saying that find the value of this x. X is the radius of the circle, right? So how do we do it? We have to make use of the tangent properties and calculate the value of x. Now, it is given that this angle is 90 degree, A is 90 degree, and it's also given that BC is 13 and AC is 12. So, by Pythagoras theorem, we will be in a position to calculate this AB. Fine. So, once we have calculated AB, we'll keep the value as it is. Now, if you look at this point O and this is the point of contact because all the three sides of the triangle are tangents to this circle. So let's assume that this is L and this is M and this is N. So these are the 3 points of contacts, right? So we know that the center of the circle and the point of contact, if you draw a line between the 2 points, you will get a perpendicular line. So this will be 90. Same here, this will be 90, right? So if this is 90, this is 90, this is already 90. So this is a quadrilateral. Sum of the angles of a quadrilateral are 360. So this also becomes 90 degrees. Now he's saying that this side is the radius of the circle, this is x, this is also x. So if all the angles are 90, two sides, length and breadth becomes x, then all the sides will be x. So it becomes a square, right? So all the four sides of ALOM, this becomes ALOM becomes a square, right? So then if length AM is x, but AC is 12, so MC becomes 12 minus x, right? So if we calculate the side AB, this is 12, this is 13, this will be 5, right? So then if this is x, entire AB is 5, then LB becomes 5 minus x, right? So if this is 5 minus x, now look at the point B. B is the external point from where two tangents are drawn to this circle and the points of contacts are L and N. Does that mean BL will be equal to BN? So if BL is 5 minus x, BN will also be 5 minus x. Similarly here, C is the external point and CM and CN are two tangents drawn to this circle, right? So if this part MC becomes 12 minus x, this will also become 12 minus x, right? NC will become 12 minus x. But we know that entire BC is 13. So we will add up 5 minus x plus 12 minus x equal to 13. So we will be in a position to calculate the value of this x, right? Okay. Now let's write it. How will we write this? We will say that OL is perpendicular to AB and OM is perpendicular to AC. You can give the reason that line joining the center and the point of contact is a perpendicular line, is perpendicular, right? Then we can say that OL is equal to OM is equal to AM, therefore is equal to AL is equal to X, right? Therefore OLAM is a square, right? So actually OLAM is a square, that is why OL equal to OM equal to AM equal to X. Okay. Now in right angled triangle CAB, BC square is equal to AB square plus AC square. So 13 whole square is equal to AB, we don't know, plus AC is 12 square. So 169 minus 144 is equal to AB square, which gives my AB as 5, because 169 minus 144 is 25. So you got AB as 5. Now, since AL is equal to X, therefore LB will be 5 minus X, right? Similarly, AM is equal to X, therefore MC will be 12 minus X, right? Okay. Now, we will write BL is equal to BN. Why? Lengths of the tangents drawn from the external point are equal. So BN is also equal to 5 minus X. You have got this BN as 5 minus X. Similarly, you can write CM is equal to CN. Therefore, since CM is 12 minus X, CM is equal to CN is equal to 12 minus X, right? So, we have written CM equal to 12 minus X, but you know that BC is equal to 30. BC is equal to CN plus NB equal to 30. What is your CN? That is 12 minus X. Plus what is your NB? You have calculated your NB. 5 minus X equal to 30. So this becomes 12 plus 5 is 17 minus 2x equal to 30. So your 17 minus 13 equal to 2x, 4 equal to 2x. So you calculated your x as 2. Clear? Now, next question. In the next question, he is saying that PQR is a right angle triangle with PQ as 3 centimeter and QR as 4 centimeter. Okay. So, let's draw this figure. We have a right angle triangle. In this right angle triangle, PR is 3, QR is 4. This is P, Q and R. This is right angled at this. PQ is 3, QR is 4. If we go by the Pythagorean triplet, we have 3, 4 and 5. That's how I made this angle Q as 90 degree. Because PQ is 3, QR is 4. So PR will be 5. And that's how this Q is the right angled. This is 90 degree. Now a circle which touches all the three sides of the triangle is inscribed in the triangle. Okay, now we have a circle which touches all the three sides. Okay, so let's name these points of contacts L, this is M, and this is N. Okay, calculate the radius of the circle. Now this is almost the same. We have to calculate the radius of the circle. Let the center of the circle be O. So if you drop a line, if you join OL, it will be 90 degree. This is already 90 degree. If you join this, this will be 90 degree. Automatically this will be 90 degree, because in a quadrilateral, four angles sum up to 360. So if three of the angles is 90 degree, automatically fourth will be 90. So now let's name this as R. This is also R. So now if all the angles are 90 degree, length is equal to breadth, then it becomes the square. So this is also R and this is also R. Fine. Now, since we know that QR is, total length of QR is 4, and if QL is R, then LR becomes 4 minus R, right? Similarly here, if QN is R, total length PQ is 3, then PN becomes 3 minus R, right? Okay. Now, after that, if you look at this Q, this is an external point. From this, if you drop two tangents to the circle, they will be same. And this is R and this is R. Similarly, if you go to point P, it's an external point, and from this point PN and PM are two tangents. So if PN is 3 minus R, PM will also be 3 minus R. Similarly, if you look at this point R, this is an external point. If LR is 4 minus R, RM will also be 4 minus R, because these are two tangents to this circle, and we know that the lengths of the tangents drawn from the external point are equal. This is 4 minus R, right? Now we know that entire PR is 5, so 3 minus R plus 4 minus R is 5, and that's how you can calculate the value of this R. So let's write it now. So how will we write this? We will write that OL is perpendicular to QR and ON is perpendicular to PQ. You can give the same reason that we gave here. Line joining the center and the point of contact is a perpendicular line. Fine. Now, you can say that OL is equal to R and ON is also R. Therefore, OLQN is a square. It's a square. Actually, you have to write this first, because OLQN is a square. That's how OL equal to R and ON equal to R. Okay. Now, what we will do is we will write that PN is equal to 3 minus R. Similarly, which is equal to PN, right? Why? Because they are the lengths of the tangents drawn from the external point. So you got PM as 3 minus R. Similarly, you can write LR is equal to 4 minus R, which is equal to RM. Same reason you can give. Now, you can write PR, but PR is equal to PM plus RM. So your PR is equal to, what is your PM? You have calculated that as 3 minus R. Plus, what is your RM? You have calculated that as 4 minus R. Right? And the length of PR is 5, is equal to 3 plus 4 is 7 minus 2R. Shift this 2R to this side. and this 5 to this side, you will get 2r is equal to 12. So your r is equal to 6 centimeters. So you have found the radius of this circle as 6 centimeters.